Hey Chem Kids, Mr. C here, and for our first video of the day, we're going to talk about sort of measurements and uncertainty and what that means. Every time we make a measurement, there is this possibility for uncertainty, and it comes from a couple of different things. Sometimes we have to estimate it. So, sometimes we have our ruler, or in chemistry, we have a nice meter stick, and it might be marked out, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And we want to measure something, maybe we're measuring, I don't know, we're measuring a cylinder of some sort that kind of comes over here like this and it goes like this. So it comes up on the end and it drops down about here. And, we only have this mark between 1, 2, 3, and 4. And, it could be 4.5, it could be 3.5, it could be 3.5, it could be 3.2 or 3.3. We don't really know. It could really be anywhere between 3.4 and 3.6 probably. And because of that, any measurement that we make in between those would be a perfectly valid measurement. And because of that, we get error in our measurements. We can't, we have to estimate what that number is. Sometimes it comes from the error of our devices. Sometimes maybe the device is off. Maybe our scale is dying in battery and it's not weighing us correctly. Or maybe our scale only weighs us out to the tenth of a pound. So we could really be anywhere, if you were weighed out to like 150.1 pounds, it could really be anywhere from 150 pounds to 150.2 pounds, or the error could be bigger. Maybe it only, weighs to the nearest 100 pounds. So it says, oh, you're 100 pounds. Well, that means I'm really anywhere from 0 pounds to 200 pounds, and I don't really like that range. So the error of our device can also play a big part in how certain we are about our measurements. And finally, we have human error. And this is one of the biggest things that happens is we as humans, as much as I don't like to admit this, I am not perfect and none of us are perfect. And I can't make a perfect measurement. I might look at this rule and say, oh, that's clearly 3.5. But you're going to say, no, Mr. C, that's 3.4. And somebody else is going to say, oh, no, 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 that's clearly 3.6. And because of that, there's all human error. We're all going to give a different measurement. Or, sometimes our eyesight isn't good, especially when we're measuring with timers or reaction time. So that all gives us errors in our measurements and how we do our measurements. We really just have to do our best with the measurement. So we have to kind of come up with a way to deal with this uncertainty in our measurements because no one wants to be uncertain about anything in their life. So that kind of comes with these ideas of accuracy and precision. Accuracy refers to how close a measured value is to an accepted value. So if you're an accurate person, that means you're very, very good. So it's really easy to picture this on a bullseye. If you keep hitting the bullseye, you're a very accurate person. You're always getting the right answer. You're always getting, 100% on tests, or you're getting extra credit, or all this other stuff. You're always scoring your goal in soccer, or hitting the home run in baseball. You're a very accurate person. Precision, on the other hand, refers to how close a series of measurements are to one another. So like in this case here, we have 3 arrows that shoot in pretty much the exact same space. Well, even though that's not the center where we want it, we still say it's precise because they're all right next to each other, which is good. So precision doesn't matter if it's the right value or the wrong value, as long as you all kind of, you have 10 different people agree, oh, the value is 3.6, even though it might not be 3.6, you would say you have a very precise measurement. So that's where precision and accuracy come in. Sometimes, like in this third situation, we are not precise or accurate. So if none of our measurements are close to each other, and none of them are anything what they're supposed to be, that would be we're not precise or accurate. But there are situations, if we have very accurate devices, that we can be precise and accurate. And that's if we take a whole bunch of different measurements, and we basically, every time we take a measurement, we get it all around in the same area. So that means that we have a very accurate, very precise measurement. So it's very different to know the difference between accuracy and precision. One way that we can deal with accuracy and precision and kind of compare that to our value is looking at percent error. And this is something that I'm going to talk about now, we're going to do in our labs, but I don't expect you to memorize this formula. But basically what percent error tells us is how different our experimental value is, our measurement, is from the accepted value, or what it's supposed to be. Basically experimental, what you got, and our accepted value is what you should have got. So let's say we're measuring, a beaker of water, and we measured that our beaker had, our measurement, so our experimental, I'm going to write as EXP, is we would say, oh, it has, 52 milliliters of water in it. But in reality, we know that it has 50 milliliters of water in it. In order to calculate percent error, we would just plug those numbers into this formula, and we would get, oh, well, our percent error is 52 minus 50 divided by 50 times 100, and we would end up getting a percent error of, 1 second, my calculator just died on me. I didn't even know calculators could do that. We would get a percent error of 4%. And that basically tells us, oh, that's pretty good. We're pretty close to the accepted value. If we get something over like 50%, that's when we're like, whoa, all of our experimental values might have been precise, but they were not accurate at all. A percent error can tell us how accurate we are. The smaller percent error it is, the more accurate our value is. It doesn't necessarily tell us whether or not we're precise, though. In order to tell if we're precise, we have to look at the actual values. Are all of our measured values close to each other? So like I said, I don't expect you to memorize this equation. I want you to know that percent error can be used to show us how close we are to being accurate. And if I gave you a lab and I gave you some values, I'd like you to know how to plug in, but we'll always go over it again. So after this, go ahead and click that little next button in the very bottom of the corner, and you're going to answer one question, and it's basically going to ask you in your own words to describe the difference between accuracy and precision. So good luck. If you have any questions, just let me know and I'll answer them right away.